Hello, this is John Mark Staude, President and CEO of Riverside Resources, for another episode of John Mark's Geotutorial. Thank you for joining us today as we look at the various processes of sample prep and sample geochemistry using Inspectorate's laboratory in Vancouver, British Columbia. Here we have rocks that are taken from Mexico, and they've been crushed and put into samples and prepped in Mexico. The boxes here are shipped to Canada, where we then open the boxes and have packets. Inside the packets are standards, blanks, as well as our material that we'll assay. They're put into batches and then taken into the laboratory in order to be dissolved and assayed for their chemistry. So now the sample has been crushed, and we'll pull out the crushed material and put it through the splitter. The splitter is going to help us to reduce the amount of sample. In order to decrease the volume, we do a second split, so we'll get 1/4 of the total volume of the sample. Now we have over 250 grams of sample. With this sample, we'll assay for gold and for other chemistry. We take this material and we put it in a small bag for the assay work. And we also take the reject material and we store that in this other bag. That in case we have to go back for follow-up samples or for any other work, in case we have a check assays or anything like that. If we're ever doing a 43-101 report or something, we have additional material. For the fire assay process, it's vital to get the weights correctly, grams per ton or ounces per ton. Here we see the scientist weighing the sample, and then he'll put it in the crucible. That'll be then assayed in the fire assay process. Here we are at the exciting part of the fire assay process. A batch of over 70 samples will be inserted into the kiln that's at over 1,000 degrees. The kiln has the flux material in each of our samples, and they'll be put in here and cooked. When it's extracted, we'll take out the bead and it'll have concentrated the precious metals. When the samples have been heated and melted into a hot, molten liquid, they'll be taken out in this batch and they'll be poured into the cast iron cooling rack. Next, the lab technician breaks away the silica glass from the silvery gold metals that have settled in the bottom of the containers. This is still hot. It's just come out of the furnace. The yellow has lead in it. The white has not yet been run and doesn't have lead. What we did is we've seen the lead button. It's then put in the furnace, and at a high temperature the lead becomes liquid and soaks into the bone material, into the cup, and the silver and gold are left in a button. That is then measured, and that's where we get grams per ton that comes across in a press release or in an assay when we look for how much gold is in a sample. Here we are at the sample digestion stage. We've ground the material and now pour it into these flasks. In these flasks, at 150 to 200 degrees centigrade, it's heated up, and with 4 different acids, including hydrofluoric acid, the rock is dissolved and the material is completely broken down, even the silicates, in order to find out what is the total chemistry of this rock. Here we are at the mass spectrometer stage. The sample is brought in this chemistry, coming through the little thin piping, comes into the machine here at atmospheric temperatures, and then it'll go through a vacuum. In the vacuum, you measure the acceleration of the different elements that reach the detector on the other side. The detector, in a matter of 1 minute, can analyze over 70 different elements. And from those 70 different elements, we can find out a complete scan of the chemistry of our sample. Thank you for joining us for this episode of John Marks Geotutorial. We've covered the different techniques in assay geochemistry, and we really appreciate being able to use Inspector's Laboratory. Please join us for another episode of John Marks Geotutorial.